Hi everyone and welcome to today's session. So today we'll be talking about agent skills. So I was first interested in this because Claude came up with agent skills, and it is basically a way to let your agent learn things on the fly. So as and when your task requires it, like for example, if you need to read a PDF and your agent doesn't know how to read a PDF, it can then refer to a skill book and look at that skill book and okay, I know how to use a PDF reader now. I know how to import stuff and how to call the PDF reader function. So all these things are not native to the agent at first. It's only when the agent comes across like, hey, the user wants to open a PDF. Then the agent will go and download the necessary information into its context and use it to do some like to know what functions to call. So that's agent skills. It's a new paradigm of agents because now the agent does not have the skill in its library at the beginning. It learns it when needed. So let's take a brief run through of how agents have developed over the years. Okay, I say years, but actually it's only 1 to 2 years. AI field moves so fast, every month is like a year. All right. So this is how the traditional agent looks like. So first up, we have a task. So you can see like this task over here. Maybe the task could be something like, read page 3 of of like maybe skills.pdf. So based on this task, the agent will then look up its skill bank and like, hey, oh, I have a PDF reader skill here. And this PDF reader skill takes in a PDF name. All right, so maybe I should use this skill to try to solve this task here. So what I'll do is maybe I'll just call the PDF reader tool. I call the PDF reader tool, and the PDF reader tool would call skills.pdf. Okay, it will execute the tool use, and then the tool will reply. The tool will return, the information of the PDF to agent. And then the agent will then look through. Okay, this will then feed back to the agent again, and the agent will then say, okay, I think I have completed the task. So the agent might call another function like reply user, and it just replies page 3 of skills.pdf contains. All right, so it's an iterative loop whereby after every single execution of a function, the agent will then look back at the past history. So the past history might look like this. Step 1, okay, the step 1 is you call PDF reader skills, and then you got the answer is like PDF contains, and then step 2, called reply user, and then you reply, okay, the reply is here, right? So there are different things that can happen in the step history. So it is a very dynamic way of doing decision making using agents because the agent does not only do it for one step. The agent takes in the previous step into consideration and comes up with, okay, what tool should I use this step? So this is the traditional way of doing agents. And for those who are familiar, the typical way of doing agents is this thing called the React framework. It's called the reasoning and acting framework. So the paper is called React if you want to look at. And this framework is very simple. What it does is that, there's a desync between the observation and the action space. So usually what you do is actually a very simple prompt. You do observation. It's like you state what the function returns, okay, and what has been done. Then you do thoughts. The thoughts could be like what should be done next to achieve the task. And then after that, you go to action. What action should I do? Achieve the task. So with this very simple React framework, reasoning and acting framework, which typically comes into 3 parts, the observation, thoughts, and the action, the agent typically takes this in, all right, as a prompt to the agent to let the agent know, what tool should I use next. So this React framework is what powers, I would say, almost all agentic systems right now. Is a very powerful framework because it allows the agent to consolidate what has happened before, to reason and plan, in the thought section, what to do next, and then finally to select the action. So it's very, very powerful. And with just like a few set of tools, like 3 to 4 tools, you can do a lot of tasks. Like traditional systems that use rule-based systems, maybe one pipeline can only do one task. You equip with 3 to 4 tools, you can do 3 to 4 tasks. In fact, you might even do 20 to 30 tasks if you can like do function one, then function two, or function two, then function one. You have different sequences of functions, and each of them can carry on from the previous ones. Okay, so this is how a traditional agent looks like. Any questions so far for this? This is basically a brief agent framework recap. You have a set of tools, you have a task, agent choose a tool for each step, keeps repeating until the agent decides, hey, I'm done with the task, and then it breaks out of the loop. Okay, or you reach a certain number of steps and then you break out the loop. All good? Okay, so this is how an agent looks like. However, what if I want to do more things like, hey, I want to do, I want to read PDF using text. So maybe like, there's a metadata text field. Maybe I want to retrieve the text field. Or what if I want to read the PDF with an OCR? So like optical reader, I use some image scanner and scan out the text from the PDF. Well, that's a possibility as well. We don't rely on metadata. Sometimes it doesn't work. Or what if I just put directly to a VLM? I skip the OCR step. I use a VLM, a visual language model, and process each page, right? So these are variants of the same function that you might want to call each tool based on different contexts, based on different situations. So you also need to provide the LLM agent with some description of what to do to call which tool. So this is what happens when we have more tools at our repository. We have more tools available. We also need to tell the agent when to use certain tools because the agent is not very smart in that sense. It's not able to like, hey, you give me a tool, I'll find out when is the best case to use it. All right. Maybe if you have some learning mechanism built in, you can do that. But most agents, you should actually define when you want to use certain tools. Okay, that is the best way. So this tool context is like giving the agent like a one-shot example of when is the best to use certain tools. Very, very important. You miss out this one, your agent will perform quite badly. All right, based on my own experience. So you need to give all the tools now, and you need to give a tool context. Okay, can you imagine? If your agent is just only doing one tool like that, that's perfectly fine, right? That's easy. That's one tool. If your agent is doing 3 tools like that, yeah, you need some context to ground it. All right, but that's not all. All right, now we want one agent to be very flexible. You type in a prompt in Claude or you type in prompt in OpenAI. Sometimes you want to do image generation. Sometimes you want to read the PDF. Sometimes you want to read Excel spreadsheets. You want to do many, many things. And wow, look at that. We just added in another set of functionalities. Maybe you want to do image generation. So you have different ways of generating. You want to generate poster, generate high resolution image, generate a cartoon style, and then the description here. So maybe you have different like models you want to call for each of this image generation. And you want to give a certain context as well as to when to use this tool. So can you see the issue here? The more general we want to make the agent, the more context we need to give the agent. And there's a chance that the agent will call the wrong tool if the context is too large. Right? You see now, just now was 1 in 3, right? You choose 1 in 3 tools. Now you choose 1 in 6 tools. Okay, I mean, of course, there's also another tool. Maybe the last tool is reply user tool, which is the like reply to the user. But if you want to choose 1 in 6 versus 1 in 3, which do you think is easier to make a mistake? 1 in 6 tools or 1 in 3 tools? Anyone? Like if you have more tools, is it easier to make a mistake or you have fewer tools to make a mistake at using the right tool? Anyone?
Yeah, for the agent, when you give it more tools, it has a higher chance to either hallucinate or you can overload its context capabilities based on the amount of context it's processing and tokens it's processing at the same time, having to take more into context during the processing, allowing possibly causing it to overload its pre-trained or pre-fine-tuned context processing.
That's right. So this is a potential issue and also quite a big issue in AI agents. If you want it to be too general, it would be worse off. Right? It would be worse off at choosing the action because there's just too many things to choose from. Yeah, just like, if you have MCQ, if you have only 3 options, the chance of you getting it right is quite high. But if you have 6 options, the chance of getting it right drops by half, like 1/6 now instead of 1/3. And if let's say we want to give it, look at this monster, look at this. We have maybe 4 functionalities. Each functionality has 6 different functions. You have 1A to 1F, 2A to 2F, 3A to 3F, 4A to 4F. Imagine that, all right? Maybe this tool is PDF reading, and this tool here is image generation, and this tool here is maybe a spreadsheet reading, and maybe this tool here could be something like calculator, right? Or math. There are different tools that you can use, a lot of different things you can do for each situation. Great, the agent is very versatile, but whoa, look at how much context you need to give the agent. You need to give the agent information about all these tools, information about when to use these tools, in addition to whatever system prompt you want to give the agent to, for security reasons, for like the way you interact with the user. OpenAI or Claude has a prompt that is like 2 to 3 pages long. I mean, they keep changing the prompt, but the system prompt can be very long as well. Imagine how much information the agent needs to know even before receiving the user input or whatever documents you want to load in, even before those input. Can you imagine how much context is there in the agent? And this can lead to severe performance degradation, right? So this is something that AI agents have faced with through the years. Okay, I always like to say through the years, but actually it's only through the months, all right? So basically, it's like there's a lot of things that the agent can put in, but it will degrade the performance. So then how can we solve this? How can we solve this? Let's think about this for a while. Hmm. Oh, yeah. What if instead of giving fixed functions, you give the agent the ability to run code instead? So you can run any code, all right? And with this any code, you may not need to predefine the functions beforehand. Like you don't have to have a function to read PDF from OCR, read PDF from text, read PDF from, I don't know, from VLM. You can just give all the information. Like for example, this is reading a PDF from the text data. You can just give like example code here. You can give another example code to use OCR and so on, and let the agent decide for itself what code to run. All right. Instead of having hard-coded tools, you can just give the context to the agent about what are the best practices for the code, and then the agent can generate its own code for themselves using their own learned context and using whatever they learned from the previous steps. You can refine the code. If there's an error, they can correct the error and so on. So it's very similar to like giving examples that are great, like one shot or few shot learning, to the agent as the context. So gone are your functions. You don't really need the functions anymore. I mean, you can also like say that, okay, we don't want to use the PDF reader from PyPDF. You can create your own PDF reader function and just put this in the code here, and the agent can use your own function as well in the executed code, right? So another detailed context maybe is how to, read documents. So you can even use command line stuff, put in the context. Okay, as long as the agent has access to the command line interface like bash, the agent can execute this stuff in the context. So it is very flexible if we give the agent the code directly to, execute. And if you are interested in this, the paper for the code execution is called Code Agent. And basically what they show is that, if you let the agent execute code, the agent can do stuff like, for I in range 5, which is like a for loop, and maybe like print name I or something. Yeah, so you can do stuff that requires you to, if you were to do a function modular function like the before that, read PDF, like the kind of functions you can call when you only call a function output, you need to call it in a modular fashion. Means like if you want to do it 5 times, you need to call the read PDF function 5 times. So in this case, the print name function, you need to call it 5 times in 5 separate steps of the agent. But if you do it in code, the agent can just typically just run a for loop in the code itself. So just with just one step, which is the code output, with one step output, you can execute all the functions all at the same time. All right. The disadvantage of this is that the error correction is a nightmare, right? So if there's an error here, you don't know whether it's the first step, second step, third step. You have an error log that you can use to find out where the program broke. But it's not as clear as, if you do it in a modular fashion. And another big risk here is security, because any code execution is dangerous. Like, so you have to do it in a sandbox. Maybe you spin up another virtual instance, run the code there, and see whether it breaks. So at least if the code breaks or the code is malicious, it doesn't harm your main computer. Yeah, by general, with all its flaws and all, Code Agent has proved to be quite versatile, and it's able to execute a lot of things at one go, right? A lot of successful agents right now are code agents. Like, for example, you have agents that can like perform any task, like Manus. I think Manus uses code output. So there's a lot of things that use code, and they mitigate a lot of the security risks and so on. And the benefit of using code is that you can possibly give the agent fewer functions, because the agent can generate their own functions, right? So again, the success of a code agent depends on the success of an agent to generate good code, which luckily happens to be the main thing that most LM companies are training for anyway. They're training for better code generation, right? So this is something that LMs can do pretty well. So yeah, we move away from the traditional function-based approach, and we ask the LM to generate code instead. Okay, but you do note that there's still this detailed context that you still need to give the agent as to like how to perform the code. Okay, because if we just ask the agent itself to use its own pre-trained data to generate code, sometimes it generates outdated code. So it's still quite important to ground the agent with good context. So it doesn't mean that we solve this problem altogether. It doesn't mean that we solve this massive chunk of tool use and instantly the agent is performant. No, you can reduce the context a bit. But the same problem still applies. There's still too much context. All right, you still cannot do everything like that, right? So how can we solve this? Right, let's think for a moment. Do we really need all this context when we solve any problem? Do we really need that? And the answer is no. You don't have to do all this context at once. If let's say this is the PDF reader context, and this is the read spreadsheet reader, we don't really need to read the PDF and the spreadsheet context all at the same time. Maybe when we need to, then we get the detailed context. So the summarized context could be like, the detailed context maybe is like 100 lines, and the summarized context maybe 1 line. Yeah. The summarized context could be just like the name plus 1 line description of what exactly is in this skill. Okay, so a good way to visualize this is Netflix. Do you all watch Netflix, by the way? Netflix? Who here watch Netflix or like uses Netflix?
Yeah, I've been binging a couple shows. Yeah.
Yeah. So Netflix uses the same principle actually. You have a movie, a series title, and then you have an abstract. I mean, the same thing for papers as well. So, like based on that title and abstract, you might be like, hmm, this sounds interesting based on the abstract, like the brief description of it. Maybe I should watch it. Yeah. Then you click and then you download the rest of the show as you watch it. Yeah. So so this is like in a sense Netflix. Like, I mean, you don't exactly need to watch all the shows to know what is in the show. Okay, but if let's say you want a particular like information about certain things, then you watch it. Then you load the context into your brain. Right? So this is one example. Same thing for paper reading. You don't store all the information of all the papers in the world in your head. You look at the abstract and they're like, yeah, I think this is interesting. So maybe I should read more. Then you download the rest into your context. Right? There's another thing to note over here is that no, since we have summarized context with like maybe a one-liner description like this, you might be thinking, hey, should I just give all this summarized context into my agent? They actually, you just this is not in Claude Skills, but there's an extension that you can do to this. You can do retrieval of summarized context based on the task. So it's something like a retrieval augmented generation. Like you can even do a like embedding match or like keyword match based on your task. So if your task say I want to read this PDF, By keyword match, maybe you can get a PDF reader skill, or by embedding match, you can do this. So let's say you have 1,000 skills, you don't have to load 1,000 summarized context as well. You can do a retrieval inside based on this. Again, with all this like condensation and retrieval, you gain shorter context, but you lose out on potentially, like, the disadvantage is that you potentially might miss out that relevant skill that is needed. So as with all things, there's pros and cons, but nothing stopping you from, if you have 1,000 skills, nothing stopping you from doing a rack on your skills. Okay, so I'm saying this, nothing stopping you. I have built my own agentic framework, like TaskGen and Agent Joe. So like these agentic frameworks have made me realize that if I do rack over skills, there's a potential chance that um you might lose out on that skill, because like your rack may not be perfect. Sometimes the user's task is quite indirect. Like the user might just say, I want to find out more about cycling, and maybe there's a cycling.pdf. So you need to read the PDF, but it's nothing to do with the task. The task is, I want to find out more about cycling. So you might miss out on the context here. I might miss out on the relevant skill. So after I've done the agentic framework for over a year, I realized that if you want to do rack over the skills, there's a chance that you might get it. You might miss it out. Yep. So while this is cool in theory, this potentially could lead to worse agents. So I've realized that what the agent really needs is, you just need to give it very few skills, very targeted skills, and let it be. Yeah, you don't do retrieval augmented generation over the skills. It's very dangerous, right? You might lose certain skills that are needed. So this is something that is cool in theory, but once you apply it in practice, there are some potential issues. So what Claude does, like, they basically do this summarized context thing. So all the skills are technically with the agent, but the agent doesn't get the details until needed. So this is a great segue to what we are going to discuss today, which is, how can we learn these detailed skills on the fly, on a need to know basis? How can we do that? And this is a very, very important question, because as agents become more capable, they are going to have more skills. And the skills need not just be skills that are given at the start. Okay, skills can also be learned through the agent's experience. Okay, we don't just want skills that the agent already knows at the beginning. Maybe the agent, after that interacts with the environment, it might find a very efficient way to read a PDF better. It creates its own skill and stores them in the skill library. So you can read the paper on Voyager. It's a Minecraft agent paper. So it's one of the first papers that stores skills in a skill library for reuse. So it's not the best executed way of doing skill reuse, but just an idea that once you have a skill and the skill works in the environment, you store it in the library, and the next time the LLM agent can access it as well. So how can we get all these skills, be it skills that are native to the agent? That means at the beginning, the agent already knows this. All the skills that are learned through experience. How can we get the agents to learn such skills as needed? So we don't overload the context with all the details. We just give maybe a very, very small summary of what the name of the skill is and what are the potential things you can learn from that skill. And if the agent wants, the agent just looks up the document to learn more. How can we do that? And basically what I just talked about is essentially what Claude Skills is doing. All right. So before we go to Claude Skills, let's take a look at this clip. So this is from The Matrix, the movie Matrix, one of my favorite movies. I watched at least 10 times. So this is a world whereby you can just plug in some stuff at the back of your head, download some program, and see, um, the character then knows Kung Fu just like that, just by downloading. So it is basically a way of saying, initially you don't have that skill, but if you want it, you can just download it into your brain, and you know it. Of course, this is not exactly how the human brain works, but this is just an example of how we might learn a new packet of information. So let's move on to Claude Skills. Okay, how does Claude Skills work? So while working on the task, Claude scans the available skills to find relevant matches. All right, when one matches, it loads only the minimal information and files needed. So can you see that there's a lot of this phrasing, minimal information. This is very important, all right? For those people who use agents a lot, you realize that, although your context length can be 1 million tokens, you typically don't want to use 1 million tokens, because if you use 1 million tokens, your performance will just will just go down, Like there's a lot of benchmarks called needle in a haystack that try to say that, hey, if with 1 million tokens, I still don't lose any information in my context. Okay, those are if you just want to retrieve exact words over there, yeah, maybe. If you want to, do more high level thinking, synthesize two different things together, you put 1 million tokens versus you put 100,000 tokens, 100,000 is going to perform better. Yeah, you can take my word on it. I've experimented it. I mean, I don't have a paper on it, but yeah, putting fewer things in context does lead to significant performance improvements in LLMs, right? And that's not hard to understand because the longer the context, the higher the chance of losing the information. All right, so this also helps to keep the agent fast while accessing specialized expertise. So what are skills? They are composable. So, they basically are modular, like they are something that can be downloaded as a separate instance. You don't have to download skill 1, 2, 3, 4, 5 at the same time. You can just download skill 1. If you need skill 2, you download skill 2. And these skills can, if you download more, you can use all together. Yeah, no problem. Right? They are portable. All right, so this one is just a specific stuff to Claude. They basically have a documentation to use certain things like skills.md that basically helps to make things in the same format for easier skill retrieval. You don't have to follow Claude when you implement skills. You can just do your own skills. Later, I'll be showing you some code as to how I implemented it. I did not use skills.md. I use a simpler approach, right? Efficient, how it loads is only what is needed, and it's only when it's needed. Okay, you don't have to put everything in the agent context. Skills are powerful. Okay, they can include executable code. They can also do stuff like fixed functions that are already given. So the skills are like, it can also be like some context as to best practices for a certain skill. Like for example, if you want to prompt a image generator, they might give you some examples of how to prompt the description. Yeah, so very versatile. Skills can be programming related, skills can be text related. I mean, if let's say the LM is a VLM, maybe the skill can also be image related. Like it can give you some examples of like potential handwritings to take note of, that kind of stuff. Those are possible as well because skills will be loaded into the agent's context. So you can load anything that the LM can understand. LM can understand image, sure, you can put that as a skill as well. Audio, yeah, you can put that as a skill. Video, yes, you can put that in the skill as well if your LM can retrieve those information, right? Then we shouldn't be calling that LM anymore. We should call it MLM, multimodal language model. Yeah, we are moving there. We are moving there. Like Gemini is very, very multimodal, accepts image, video, and text. Soon it can accept video. If I'm not wrong, maybe it can accept video, but very small video. But yeah, we are moving towards multimodal language models, and that means the skills can be multimodal as well in terms of what we put in the skill.
Sorry, can I clarify something?
Yes, there you go ahead.
I don't get what do you mean by audio as a skill.
Okay. So you see, the skill itself could exist in like a README file with all this information. So, imagine if your README contains images or audio, you could also feed that into the context of the LM.
But isn't that just the context?
It is the context.
So
Yeah.
my question, I guess, is how do you distinguish skills from context?
Context belongs to the agent at the beginning, the initial context. Skills is more like downloadable context. So as and when needed, the agent can feed in more context. So
that's quite different from my understanding of skill. So my understanding is like skill is the ability to do tool calling or function calling.
so this is Claude Skills. So Claude Skills is basically they feed in an additional document to the agent so that the agent knows how to do more things.
This sounds like they are blurring the lines between context and skills from my
Yeah, I mean in terms of Claude Skill is more like um I mean it's similar to putting more things in the context. Although the practical implementation that they did is slightly different because how the skill goes into the context is actually in the tool call. Later I'll show you the
okay, sure.
example. Yeah, but the idea is that you don't learn everything at the beginning. You learn only as needed. So if you need the PDF reader skill, then you learn the PDF context, PDF reader context. And all these contexts, they are the kind of things that, it's like whenever you need to, you can download them. And what I'm saying is that these skills can be multimodal if your LLM can accept multimodal context. All good? Okay, I just take it as good. If anything, just feel free to let me know if you need any clarification. So this is an example from the Claude website. You can go and take a look at Anthropic website with this, equipping agents for the real world with agent skills. So this is agent configuration, very typical agent. You have a system prompt. You have a lot of skills as well. And just take note, these skills are quite different from the normal skills or tool calls that people have. It's not the name and the function parameters. No. It's just name and description. So this is equip skills are just name and brief description. So if the agent wants to, the agent can then load the more detailed description over here. So like for example, BigQuery, the name and description maybe is like one liner, but if you want to load, whoa, you can have this whole skill.md, which then could even link to new details about more things. So like it's like a file directory reference system. You go to skill.md, the skill.md can say for information on data sources, go to data sources.md. For more information about BigQuery rules, go to rules.md. It's like those README guides. They say if you want to find out more about a particular thing, go to page 1. If you want to go to find out more about another particular thing, go to page 2. And they enable that as well. Like it's a skill directory. It's not just one thing, it can also link to more things. And that's quite interesting because it creates a hierarchy of context. Like you don't load all the context at one go for a skill. You can also go through the hierarchy and load as needed. All right, so all this points to a certain skill here. Of course, MCP, Model Context Protocol, is quite big. You can also have tool use as a MCP server. Your MCP server can execute different functions. Like maybe one can do reasoning and planning, one can do, you can even have a PDF reader MCP. Like MCP to me is just an abstraction of a function call. Like you can have the function live in your server, you can have a function live in other servers. Personally, I don't use MCPs because I find them a little risky in terms of security. Like you're offloading your task to someone else's server who knows what they can do with it. So yeah, I mean, but MCP is also a potential tool that you can use. So this is the idea, and the agent has a virtual machine that can run code. So you can run Python code, you can run Bash code, which is like command line. You can also run like website related code like Node.js. So this is the setup for your agent, and take note that this is a virtual machine. Very important, because if you want to run code, you better not do it in your own machine. All right, there's a very high chance you get security lapses if you do that. Yeah, so if you spin up another virtual instance, maybe use a Docker or something, at least if there's any damage, the damage is done in the Docker file rather than in your own computer. So with code agents, as I said, you can use fewer functions because your agent can write its own functions, but there's more danger as well. So, you can mitigate some of these dangers by putting it in a separate machine. All right, so this is how the agent framework is defined by Claude. Very, very similar to what I've covered earlier as the code agent thing. So what we can see now is that this equip skills point to something bigger, something that you can download into your agent. All right, so how does a skill work? As I said just now, name and description, known to agent at start of runtime. If the agent thinks the skill is useful, okay, it will read whatever file is needed, okay, to feed into context of the agent, the details of the skill. The agent can then use these skill instructions to write the code as needed to execute the skill. So in summary, skill is just dynamic context given to the agent, all right, to know how to do certain things. So how does a skill.md file look like? So for example, in the PDF reader skill, which is the example given on the Claude website, your name could be like PDF, as simple as PDF, or they can call it PDF reader. And then the description is here, how to use the PDF toolkit for extracting text and tables, merging, splitting documents, and filling out forms. Okay, just take note that all these things actually, if your LLM is very well trained in the pre-training data, you don't really need a skill to do this. But the reason why Anthropic created a skill like this is because the LLM itself is not capable of, okay, these are my own words, right? But these are my own words, but you should only use a skill if your base LLM capabilities cannot do this, right? So if your LLM capabilities are not able to like maybe do PDF reader like this, or maybe it's outdated because it's trained on outdated code, then there's a need for a skill to give it updated practices about how to call certain functions. So in this case, for this PDF skill, the markdown, which is the skills.md, the detailed description of the skill will tell you like, hey, if you want to do certain things, what do you do? If you want to read the PDF, you call the PDF reader. If you want to use OCR, you call Tesseract, PyTesseract. If you want to split join documents, maybe you call another one, different modules. So it's not just limited to one package. As you can see, the skill itself is not package specific. It just tells you the various scenarios, what code you can execute. And it's not only limited to code, you can also give it descriptions as well. Like as what I said before about image generation, you might give it different descriptions about what to generate for different contexts. Like I recently we have a episode with Tianri also. Like Tianri is a generative AI prompter. So if you could just put his skill book of how to prompt videos inside as a skill.md, you can have your very own video editor skill that teaches you like with what images, what prompts should you use. You can put that as a skill.md. Yeah, so it's not restricted to just code. You can also do prompting guides as well in your skill.md. All right, so this is just a dynamic context that can be fed into an agent as needed, and very versatile because you can feed any context. You can feed multimodal context as well if your agent can read multimodal stuff. All right, so this is how a skill looks like. And the skill itself can also point to more things. It's not just the skill.md that is loaded. I mean, initially, yes, you only load the skill.md, but after that, you can load more things. Like, for example, you can say, it's like a table of contents or like a readme guide that says, if you want to find out more about what, go to page what. So this is like page 1, and this one is like page 2. So initially, the agent does not load the reference.md and the forms.md. It does not load that. It loads the skill.md first. And then if let's say, the reference.md is important because we want to find out JavaScript libraries. The agent can reason that. Then the agent can then load this one next. All right, so it's a hierarchical way of loading your context. So there are different levels of context loading. So as I said just now, the first level is the skill.md is always loaded when the skill is decided to be loaded by the agent. Okay. Oh, sorry. Skill.md metadata is the name and description that is always loaded to the agent at the start of the runtime. Okay. And when the agent wants to run a skill, it then reads the skill.md. Right. And there's some restrictions. Your tokens must be less than 5K in Claude. But if you don't use Claude, don't care about this tokens thing because like this is just Claude specification. You can use Claude skills without using Claude. All right, you can just do the skills yourself. Later I'll show you how. We have some code to demonstrate that. All right, then we have some bundled files. As needed, you can load them as well. So This one in Claude's side is unlimited. So these are the other things like reference.md that you saw earlier, that the skills.md might point to those files. You can load them. And also these bundled files can also be pre-built functions that, you just want the agent to use these functions. So like give you an example for this pre-built functions. You go back to this thing here. Like maybe there are some functions that you already know that are quite useful and won't change too much. Like for example, extract fields from a PDF form. In your forms.md, you can reference the extract fields.py, and the agent can then call the functions that you built in this extract fields.py. So all these things can be given to your agent. Okay, you can give pre-built code in addition to just the README files, the markdown files. Right. I'm gonna stop here for a while. Any questions so far about how the Claude skills work? Before I go on to give an example of how it works.
No, I think it's pretty straightforward. I think my only question was, in your framework in Agent Joe, the memory and the tool assignment, the function assignment, I was trying to look through the code again. It is pretty similar, but I think this one just has more layers of hierarchy to the context assignment and like the context retrieval. Because I think yours, from what I understand, is you have the function name with the descriptor and then the actual function. So it's like a one layer of abstraction, pretty much, where you just have like one layer of like job description and then the actual tool itself. I think it only goes down one layer deep, but you can correct me.
Yeah. Actually, the memory context loading in Agent Joe is basically like you can add in your own context yourself, less additional context. But if you want to if you want to have more context built into the agent, you can just have a function like give context function. And then when you call the function, the output of function is the context. That's enough already to do the context loading. But it wasn't built for this. So later I will give you an example of how to do this. I didn't use Agent Joe. In fact, actually nowadays I realized that agent frameworks can be a bit more rigid. Like so I'm actually more towards the structured output passing layer now. Like you just use many structured output passing calls, you can replicate what an agent does quite easily. Yep. So I think that's more or less going to be the future of agent programming. We will try to avoid frameworks as much as possible because it's just too rigid. Like each framework is created for a certain kind of way of doing things. But if you want to do more adaptive things, it's going to be tough to change it. Yeah. So I'm actually working on some improvements to the agent framework, will be out soon. And the idea of this dynamic context loading is something quite crucial and quite nice to have. I really like what Claude did. Yeah. I may not agree with everything, but I like most of what they are showing here. Any other things?
Can I add one more comment? Like
Yeah.
regarding your remark on like agent agentic frameworks are rigid. So
Yes.
recently I watched this you can interrupt me if it's too
No, go ahead. Go ahead. Yeah, we have
too
time. Yeah.
sidetrack. So I watched this I think Hugging Face hosts the chief scientist of Manners to give a talk. There's a recording on YouTube. You can also have a look. I'm not sure if I watched it. Like he also mentioned this, like for the past few months since they launched their agent, right? Keep removing stuff from from the framework. Yeah, the scaffold is too much, and as the model gets better and better, like they also realize that you should remove things instead of adding more things. Yeah.
Yeah, definitely. As with all frameworks, they are good for certain pipelines, but if let's say you want to do a bit more generic stuff, it's best to do it from scratch. Yeah, so of course, yeah, you don't go too much to the root, like you don't do assembly code, but instead of doing like pre-built agent blocks, maybe you just go LLM blocks plus plus. Like the LLM blocks can do more functionalities, but it's still going to be an LLM call. Yeah, you work from that block.
Yeah, in some sense, a lot of purpose you intended to achieve with agentic framework has been uh, as your model post-training gets better and better. So a lot of things you want to do actually with agentic framework, you can achieve the same thing, but with more flexibility, with better post-training, especially with reasoning model. Yeah, that's a lesson I learned.
Mm.
Yeah.
Yeah, and different models, actually different LLM providers have different quirks that you need to prompt differently. So having just one agent framework itself might be difficult to incorporate all these different models. You still need to change the prompt based on the model.
Okay.
Yeah, I agree with JU a lot. He brings up a really good point about current models. Just like the performance boost we're getting with consistency and with the expansion of their skill set and their what do you call it? Not adaptiveness, but their generalization in the context of language processing and like language reasoning. Oh, if this, then this kind of agentic tool calling. The It kind of seems to be shifting the meta of at least the neurosymbolic frameworks where they're starting to focus on specialization instead of like agentic generalization, so to where like you've been saying, John, where you focus the model with a fixed pipeline that's very precise and robust, and then you use the LLM agent as almost its own kind of tool call, if even, and just kind of use it as a way of like routing uh, for more advanced reasoning, more semantic or general reasoning that you can't hard code. So you need kind of like a language semantic router that's capable of that higher level language reasoning and decision making, but making it robust enough in the pipeline to where it can't hallucinate or it can't break away from form and affect errors in the later parts of the pipeline, and kind of using the LLM as part of that pipeline frame workflow and focusing it on a singular kind of like goal of just being a basic semantic router or a basic reasoning router, pretty much. That kind of
Yeah.
seems to be what's happening.
You basically described the remainder of my slides for me. So thanks. We will come
Oh,
to that. Yeah. So I think that is very important. Whether or not an agent is all you need. We will touch on that later. But I think that's it's good that we have this discussion because now we're gonna go on to the example of how Claude Skills works. And then after that, I'll show you the implementation of Claude Skills. Okay, then we can discuss more after that. Right, so this is how Claude Skills work. So initially, the context contains the system prompt for the agent as well as the name and description of all your skills. Okay, note this is a bit different. It's not name and description of all your tools. It used to be tools, where it's like you give a certain function name and function parameters and you call the tools. Now it's skills. So basically, the user will come out with a task like fill out this PDF based on what we know about me, and this is the PDF. Okay, notice that this user is very helpful because it talks about fill out this PDF, fill out. So this actually matches quite well with the PDF filling skill. Okay, but most of the time the user wouldn't be that helpful. The user might just say, write what you know about me. Or like so it may not match that well to the skills. Just to give an example, right? But in this case, the user is very helpful. In most demo cases, the user is very helpful as well. Yeah, the user will just give the keywords necessary to trigger the skill or the tool call. Right. So this say that yes, the Claude will say yes, I'll use the PDF skill to help. It triggers the PDF skill by reading the skill.md of the PDF. So you can see the tool result says the contents of the skill.md file is dot 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 dot. So notice here, although I say this is a dynamic context extension, the context extension is not here. Okay, the skill context extension is not in the main context. Okay, it occurs in past history of steps. Because when the tool returns a result, that result of past tool call is appended in the context of the main agent as like the past history of what has been done. So in this case, the tool result is in the history, but it's still in the context of the agent. So I guess it's still right to say dynamic context. It's just not in the context at the start. So once the agent reads skill.md, and the skill.md also says that you can read forms.md to fill up. So it decides to, hey, let's also read the forms.md. So that is how the hierarchy is done. Not too different from Claude Code, I guess. Like Claude Code also have many files and stuff, and they can decide to read certain files. So the way that they did this, very, very similar to how Claude Code might have read your repository. Okay, in this case, we just made the skill a repository. So it's like, wow. All right, so they reuse quite a lot of things that they have already done. Quite innovative, I would say, because it's able to make what was a function call for a tool become a repository of a tool or of a skill. So and you can use tool calls to just reference those skills. Quite ingenious, I would say. Yeah. Downside for this, I mean, of course, the positive side is that you can reference the skill as needed. Downside, can you imagine all these tool calls taking up time? So this is increased latency. Okay, for loading on demand of your skills, right? So, I mean, in the future when LLMs become much faster, this latency probably is not going to cost much. Okay, but I just want to highlight that on-demand skills have a latency penalty. You will need more steps in order to load your skills. And as I went to try out this just now I tried to implement skills myself. Sometimes your skills might load and your agent might not know what to do also. Like so your skill.md needs to be quite specific in the wording of how the code is called, what functions to use. Anything wrong in your skill.md, you might lead to inability to execute that skill. So it's not as straightforward as giving a function for the agent to use. I think function name and function parameters, agents can do it quite well. Self-generating code can lead to errors. All right, and that means your skill.md needs to be crafted in such a way that it's quite obvious for the agent to know how to generate the code. Right, you cannot just give any instruction inside your skill.md. It needs to be worded very well. Think of your skill.md as a perfect reference document. Right, if your reference document is wrong, the agent will learn the wrong stuff as well. Or if the reference document is vague or not clear, then the agent will not be able to execute as well. So it's not a cure-all. This skill window is additional context. You still need to prompt the context well. And the context, I think I need to specify this. The skill context needs to be catered to how the agent interprets text or information. Okay, so there will be different quirks according to different LLM providers as well. Like if your agent is more used to reading code, then you should write in code. If the agent is more used to like getting examples based on functions, then you should use functions. So it needs to cater to the agent that you are trying to put this skill to. All right, so it's not like one skill can use for all agents. Nope, it doesn't work that way. The skill is still based in the context window of the agent. So you still need to prompt it in such a way that the agent can understand. Right, very important information. Okay, I just want to highlight this because Claude Skills make it look like the skills is like very versatile, any agent, anything. No, the skills is part of the context. You still need to prompt it properly, right? So how do we run the executable scripts? So for example, if let's say you have a forms.md calling this extract fields that gives this input.pdf and fields.json, all right, you can ask the agent to run this. So when the agent sees this, maybe it will call a bash tool that will call this /extract fields.py, and then maybe you can put like user pdf.pdf, and then maybe the output fields can be like your fillable fields, right? You still need to put your fillable fields in. So your fields.json, you could have like a name, like the fields that you want to fill in. Yeah, fill in this field. Yeah. So you need to still put in the information in the sense of what is required. And you see, if you want to do a bash command here, you need to put a / quote here because no, it's a string, so you need to escape characters for inside the string. So something like this, in order to use the extract fields.py, you can run this as a tool call after reading forms.md. Okay, so this is something that I don't quite like about JSON, because like a JSON output format, you still need to do all these escape codes. Later, I'll be showing you my latest output parser. It's got parse YAML. So instead of passing output as JSON, I pass it as YAML. I avoid all these issues with quotes and backslashes, right? Because YAML, there's no need to use a backslash. They have different formatting to get this out. So yeah, so this is how you would use like output for your agent to run that code. Yeah? You can run the bash command, or you could run a Python file that calls this bash command. Yeah, many ways to do that. Yeah, so this is how we run the executable script. Comments and thoughts before we move on to the live code demo. Okay, I think let's move to the code demo. Let me share my screen. Yeah, okay. Can you see this agent skills thing? I'll upload this later. Yeah, I was just playing around this morning. Can you see so far? It's called agent skills. Okay. So here, as I said, like I use so strict JSON is my own library that is an output parser, structured output parser that takes in certain things like a user system prompt and a user prompt, and then outputs things in terms of output format. So I created this output parser because I wanted something easy to use across different LLMs. And in this case, the output parser for parse YAML would output things in YAML. And then after that, it converts to a dictionary for you to use like this. Yeah, so you can do stuff like list, dictionary, list, code. Yeah, so this is how to use strict JSON. Or in this case, this is the parse YAML version of strict JSON. Yeah, this is the newest one that I created a few months back. Okay, because I realized that if you want to output code, you output JSON, there's going to be a high chance of error because of all the quotations and stuff. So parse YAML, quite easy to use. You just use parse YAML from the strict JSON library. Then after that, you define your own LLM. Okay, you can just put system prompt and user prompt basically. Put in your client. Here I use OpenAI because I have a few $100 credits to burn by next year. Yeah, so I'm trying to use it up. All right, so we have this LLM call that we can use it to let me just run this. So we can just restart the kernel. Okay, a bit risky here because if it doesn't work, then it doesn't work. So I'm just going to do it live right now. Okay, so we can have the LLM generate the 5 names, and here the names could be boys. You can see this is the output for the LLM. So it just takes in the system prompt and user prompt. So if you want to use a structured output parser, you can use parse YAML, or you can use stuff like instructor, or you could use if you're using Gemini, you have a structured output parser built in already. But in general, I don't think the structured output parser is very versatile, so I created my own. So you can see over here, we can have a structured output parser that generates names, meanings. Here, it generates quite a number of things. You can just put at the end what as a type hint what you want. Okay, so you can put list string, or you can put dict and so on, or enum. So this will force the output to be one of this. So backend, this will convert into those kind of structured output. What do you call that? I can't remember what's the thing that I use. But basically, it's something that can give you conformity to this data types. So it ensures that these data types are met, and you can see this the output. So as what I said earlier, I think agentic frameworks, all you really need is a structured output parser. Okay, you don't really need the agent framework anymore, because with this structured output parser, you can do a lot of things. So you can see just with this system prompt, you can generate so many things, and then each of them, you can then go to names, meanings, and so on. You can get the exact fields that you can use for downstream processing. So you can either do ints or type ints. Very flexible. You can just feel free to play around with this parse YAML. Yep. So this is my latest output parser. All right. So now we need to create the skills. So where's my skill? Okay, I think we can delete this. We don't need the class skill anymore. Initially, I created a class, but I realized that all we really need to do is just have the skills.md. So this is the skills.md. You see, how do we use the PDF reader skills? So over here in the PDF reader, I have a few functions like read PDF page, PDF info. Okay, previously I let it generate its own code, but I realized that GPT-5 is not that great at generating custom code, so I changed back to modular functions. So maybe if you are using Claude code or Claude, maybe it can generate custom code quite well. Then you can change this according to Claude's like what is good at doing. So here I realized OpenAI models are great at doing modular function calling. So I went back to modular function calling. Okay, so it's more than modular function calling. You can also give it stuff like more of the hints as to what to do. Make sure you must install this. Yep. So these are some additional things you can add on in addition to just like giving the functions. And your skills.md need not just be restricted to stating the modular functions. You can also give an example of the code that you can generate. But prior to this session, I tried to let the model generate its own code. It keeps giving me errors. So I reverted back to modular functions. So as I said, the context here for this skill, it depends a lot on your LLM. So use what your LLM is good at doing. And that's why I feel like structured output parsing like that is better, because you can cater your system prompt and user prompt to what your LLM is good at. Like you don't have to use a fixed system prompt in the agent framework. This is actually all you need for agents. We have a PDF reader skill. We define our own functions like read PDF and so on that the agent can use. Of course, you can just give this direct to the agent, but here we are demonstrating that the agent can take one more step to find out what functions is needed before it uses it. All right. So as an example, like this read PDF page agent skills, you can just read this. So what is this agent skills.pdf is none other than the slides we are using today. So yeah, you can read this PDF and it can come up with like, this is the stuff for this page. So next, we create some skills for you to execute the code. So execute function is basically like given the function name and the parameters, execute it. All right. Reply user is just reply the user. Okay. So what I realize is best, right, is let's say you have a task, like what is in page 3 of this agent skills.pdf. Okay. So what I will do first. All right. In contrast to what Claude Skills is doing, whereby like we use the skill as a tool call and then load it during the cycle of the user's prompt. I find that it's more performant for you to actually call LLM parser to just find out what are the skills needed. So for example, this is the agent task. All right. And then based on the agent task, I can get what are the skills needed. So you can see the output is this REST skill names is PDF reader. So I realized that actually out of all my available skills, I mean, over here there's PDF reader. I can add more skills, like you can have an image generator. So you can put like information about prompting an image generator to generate image. Use this if you want to generate images. Yeah, something like that. You can add in more skills here. You can pass this into the LLM. The LLM will see that this is your task, and then it comes up with the PDF reader. So if let's say your task change, like then generate a flowchart as an image. So if your task has two parts like this, generate a flowchart. Okay, maybe we need to be a bit more specific. So we want it to use the image generator. So you see stuff like this. This is why I say, if you do like some form of a retrieval generator kind of way to give more skills, you might miss out on stuff. Like here, it might even miss out that, you can use an image generator. So there are different ways that you can use this to prompts. But I realized that, rather than putting the skills name and description all in the main agent loop itself, because I realized the agent can keep calling the skill, can keep reading the skill, and like it adds more complexity to the main agent loop. I find that what's better for skills is that you put this as like a preload, or you can call this function to find out what skills needed at any point of time in the agent's runtime, and just put in the additional context as needed. So this is just how I implemented skills. I find it to be better than what Claude Skills is doing. So you just take the skills here and then you just put in the stuff in the skill context. So you don't have to do the bash read of your documents, which might fail because you might read the wrong path and so on. Simply just put in all the stuff that you want as a skill. Let the LM choose what it thinks is needed. Then load it into a skill context like this. So this skill context will then be used in the agent loop. So let's go to the agent loop. Okay, so much like Andrew Ng's course, I've decided to go native, just use LLM parsing to show you how an agent is done. So this is just your agent. This is just the agent. You see, just just a few lines of code. This is the agent already. So this is how I did it. I didn't spend more than 10 minutes coding this, to be honest. It's not difficult to code. Like so, maybe because I've experience with agent frameworks. Like I'm just saying that it's so much flexible if you do such a loop like that use agent frameworks. Is it like first you have a history for what two calls you have done? Maybe you loop for 3 steps. Each step you say you are to execute the user task, and the user task you can put in the user prompt, or you can put here also. Yeah. Then you can have a past history to tell the agent what has been done so far. Then we give an additional context here. And what's this additional context? Whatever skill you have loaded before. All right, then these are the functions that we can use in addition to the additional context. So maybe these functions could be like the set of core skills that core tools that you can use. So over here, I only give it reply user. Okay, we can also give more. Yeah, so these are the form that very, very simple things to do. Like in the future, I will have a way to like load any function and have this string here be given to the agent. So I'm working on it. So I feel like this is way more simple and easy than an agent framework. Like it's so easy to see what's going on. Okay, use only the functions required, provided, including those in additional context and nothing more. Function have no parameters, then return an empty dictionary. There's some prompts to just tell it how to return. So the output format is like, what are the thoughts? So, previously we have the observation. The observation is like this, past history. We are using the React framework here, observations, thoughts, what thoughts to do next, and then the functions. Okay, here I didn't even bother to, do a type check for the function params. Why? Because if the function fails, this will be in the history and then it can correct itself. So very, very flexible. And I realize that LLMs nowadays, they hit the function params types quite well. So you actually don't really need to have a type check. Yeah, so this saves some. I mean, you can also have a type check later because when you come up with the function name and function parameters, before you execute your output, you could do a rule-based type check. No problem, you can have a type check here. Yeah, but this is so easy. You execute your function with this function that I created earlier, that it basically just runs the function. All right. So after that, you can put your function summary, which is like this function executed with what parameters, and this the output. And then yeah, you can then end when the reply user is called. So let's just run this and then we can see what's going on. So you can see step 1, it reads the file path agent skills. Oh, wait a minute. It read the PDF page. Okay, let me just try to reset the context again. So okay, so let's run this again. So first it should be reading the skills. Oh, so sorry, it already read the skill already because the skill is here. So first it read the PDF. Let me see what happened here. Your prompt was flagged as potentially violating. This OpenAI, so many security issues. Yeah. So first we run agent skills, read page number 2. Next, we reply the agent. Page 3 contains this. Okay, what did it reply? It replies this one. Yeah, so this is actually page 3. Okay, but it read page 2 just now, so I'm not really sure what's happening. Okay, you know why? Because the LM itself, it actually saves the context inside here. So we have to change the LM to, maybe GPT-5. It's just a quirk with the API. Sometimes let's run this again. Let's run all this again. So first, it finds out what skills it needed, the PDF reader skill, loads it in the context. Then after that, what we do is we run the agent loop. Step 1, it reads page 2. Step 2, reach page 2, and then reply user. Okay, so it replies that this is the page 2. Okay, which is weird because we asked for, what did we ask for? We asked for page 3. I replied page 2. So, this is what happens when you use an agent. Maybe we ask for page 5 instead. Let's try page 5 and see whether it works. So now we ask for page 5, and then you can see over here, hopefully it will. Oh, it's reading page. I see. Okay, I see. So, okay, now it's page 4 and then page 5. So you can see that this is a very good example to show you how the agent might fail. You see, it's reading page 4. I think maybe the pages might be in 0 numbering. Okay, but let's take a look here. In this read PDF here, in the page number, yeah, it starts with 0. So this is why it's reading as page 4. So let's see what's page 5. So page 4, page 5. Let's see page 5. 1, 2, 3, 4, 5. Page 5 is this one with a lot of tool calls. And it's this one here. It's actually page 4. Too much information, right? Here, this is page 5. So it's actually reading the right thing. So over here, it's calling it wrongly because you see, this is a thing about context. So let's fix this. Okay, let's fix this together. So what we do here is this 0 index. Okay, so over here, if user keys in page 5, call page 4 instead. Something like that. Yeah, just put something like this. And we can run the code. So actually the initial way of it running the code, when I asked for page 3, called page 2, yeah, that was actually correct. So you see, calls page 4, okay, and then reply user. Okay, so sometimes, OpenAI might repeat the thing, no problem. This is just a quirk of the model. All right, so you can see that in the end, we reply the user with the page information. And this was with a function that was not in the context at all. There's no context here. The only context is the additional skill context, which is this one here. So you can see this is how we load the skill in the agent. In Claude Skills, what they do is that they put the skill loading as a function that you call here, which is what I tried initially, but it got quite bad results because sometimes it didn't call the function. So I realized the best way is still for the agent to have a fixed way to load the context like that. And then after that, run the agent with the context. I think that still loads the best. But perhaps Claude in the pre-training data has been trained to reference certain files and so on that OpenAI models may not be trained for. So you have to adapt this skills thing for your LLM agents. Okay, it depends on the LLM. All right, so that's more or less how agent skills is done. So right now over here we do function name, function parameters. Initially I have one function called generate code or execute code. Then I realized that it has a lot of errors. So again, depends on your LLM whether it's well prompted for all these kind of things. So yeah, that's more or less the demonstration for agent skills. Really is just load the skill on demand, and then after that execute the agent loop. Yeah, that's more or less Claude Skills. Questions?
I have one question on how you parse your PDF. So when you ask it to read page 5, I noticed page 5 the all your skills is presented in a diagram, right?
Yeah.
So how do you effectively feed the page to agent, but also trying to preserve the you have something like a flow chart on the page. Is it able?
Oh, right. If you really want to do this, you have to use a VLM to process this page and then ask for a description. So this is currently not in the agent skills because in the agent skills, if you look here, we are just typically using the PyPDF and just read the file.
Okay.
Yep.
So you just extract the text as a sequence.
Correct. It just
Okay.
extracts in the metadata of the text itself. But if you really want, you can put read PDF page by image or something like that. And then you can call either like OCR model also cannot get your flowchart, but you will have to call a VLM to pass in the PDF. So all these things can be as a skill function, and then in your skills.md, which is this one here, you can then just like give an example about what to do. Yeah, so for example, you can say that by default, try the pass PDF by image first. If that fails, then you can use the PyPDF. Yeah, something like that. You can just put that as a skill. And essentially, this will just be fed into the context of the LLM, and the LLM will execute it based on what you write there.
Okay.
Yeah. Any other questions? I'll link this document. I mean, I think this is a very like fundamental way of doing skills. It saves a lot of complexity, it minimizes the complexity of Claude Skills, because you don't have to call the skills on the agent loop itself. You can call the skills pre-agent loop. You can just load this. And the beauty of this is that you can even call this thing in the middle of your agent loop. You can just, at the end of every step here, you can even call another one. You can even call another, skill additional context update here if needed. Yeah, you can call another one. Let me just put in here that you can just update this skill context based on this thing again. Like you can, instead of your task, you can also put in the history here. You can put in inside here. So every step, I will get a dynamic context that is suited for the next step. That all can be done. Yeah, so very flexible.
Sorry, another question.
Yeah.
You just mentioned Claude Skills. Give the agent the skill during the agent's taking action, right?
Yes,
Not
yes.
before. Then how I don't understand, because how if you don't tell the model in priority the exact functionality of the skill, then how does the agent know which skills to read during the execution?
You tell the agent the name and description inside here. So in Claude Skills, what will happen is that you have your PDF reader skill here, and then like you
So this is still given before the agent take action, right?
it's given in the context of the agent. So the agent will then need to call this function for the additional
As
context
in the
for the skill.
description, is it given in the system prompt?
It's given in the system prompt
Okay,
already at the
okay,
start.
okay.
Yeah. Over here, I just remove all this because I have tried giving it the system prompt before this session, and it failed quite miserably with OpenAI. So so I do a two-step function. So this is actually a great segue for my next half of the not next half, the next 10 minutes of the talk, because I'm gonna say like what I think is the best practices for agent. Okay, I'm gonna stop my share here. I'm gonna go back to the slides. Let's just finish the rest of the slides in like 10 to 15 minutes. Sorry for the delay. I think what you can see from this example is that agent skills is not a cure-all for stuff. It's still just a way to prompt the context. And one thing that I always have in mind is that if you want to really minimize the context for your one agent, why just use one agent? Why not? If you want to do a PDF viewer perfectly, why don't your agent just you already have the name and description, right, for your skill, right? Why not just use another agent or like a fixed pipeline to execute the skill? Okay, you see, this is the thing I have in mind is that if a Claude agent, or rather if an agent downloads the skill into its context, can you imagine that this context, there'll be a context bloat in the main agent if you only have one agent. But if you download the context in your other agents, in fact, all this you can be pre-downloaded. No need for runtime download of context. Why is there no need for runtime download? Because the agent is only meant to do one thing. All right, so you can already put that context all the time. So why do you want to bloat the main agent with all your context of all the skills? When you can just, skills already put name and description, right? Then instead of reading the .md file, why not you just call the agent itself? You want a PDF viewer, you just call the PDF viewer agent to view your PDF. Oh, why can't you just do that? You want the image generation, why not you just call the image generation agent? What's stopping you from doing a hierarchical agent structure? Why do you need to have all your dynamic context loaded in your main agent? So they want minimal information sharing, yes. Minimal information in the main agent, I agree with that. Just use sub agents. Why can't you do this? Yeah, so I really think this is like better than what Claude Skills is doing. I have tried out Claude Skills and I found it to not work for some instances. Like it's not as cool as advertised. There's still issues with loading the right skills, and even you load the right skills, your context might just be so long you might miss out on how to run the code needed. So no, why not modularize your stuff? This is actually a better approach. In fact, like this is what I recommend people to do. If you really, really want to do agents, you should try to subdivide your tasks such that each agent at most only takes 3 to 4 tools. Okay, don't exceed more than 4 tools. Performance drops quite significantly after that. Again, there's no paper on this. It's just practical experience that I have and coding the framework. So yeah, why can't we just do this? Yeah, why do we need Claude Skills? So this is just one thought that I have. We can discuss this later. Let me just run through the rest first. So this is Agent Joe. This is the framework that I've been like my last year of PhD. It started with TaskGen, then now the open source version is Agent Joe. So this is the kind of thing that I'm trying to implement. So like, why can't you just take a meta agent and then like if you want a function call, you can call a function. I mean, of course, you can call code as well as a function. Okay, then also sometimes if you have more complicated stuff, you can put to an inner agent. And this inner agent could be something like, your skills.md, additional skills needed that, the main agent may not need. Okay, because it's just only for that one instance, you can just call that inner agent and do it, and that's it. Like you don't really need the main agent to know everything. So the cool thing about this is that, your agents actually can have a common shared memory that you can like pass variables to each other and so on. So this was the agentic framework that I did last year and also a little part of early this year. I realized something, the agent framework is not needed. So this is my revelation. So after I talk all this about Agent Joe, I realized that, structured output passing is all you need. So I'm going to, this is just a teaser. I'm going to implement more LLM passing plus functions. For example, an LLM parser that takes in functions so that you can do function calling. Yeah, something like this, I think it's much more versatile than having a fixed agent block and have a shared variables and so on. Because actually all this shared memory here, you could just implement all this using your own like vector DB, or you can call like a JSON file or whatever. Like basically you can do all this in your own practices. You don't really need an agent framework to dictate what should be a shared memory and so on. So I think it's more versatile if you just use structured output passing. So this is the direction that I'm going to take this, right? So this is after experimenting over months, I realized that the agentic framework is a bit of a bloat that can be removed, right? But the idea of Agent Joe will be preserved, all right? I still like this idea where you only modularize what you need. You only call what you need when you need, and you don't put the context in the main part when you don't need to. So you saw in the Claude Skills code demo that I did earlier, I executed this principle. So I basically don't bloat the main agent with additional functions to read the skills.md. Okay, because that's additional bloat, that's more functions needed. I basically do a pre-call to the agent loop to ask what functions do you potentially need. And then I just load these functions in the main agent. So by doing the pre-loop, it helps to save a lot of potential complexity in the main agent. So the idea is make the agent know as little as possible as what the agent needs. Okay, and that's the core principle behind this. Okay, so this was Agent Joe. I think the principles still remain, but I'm heading towards the more of a more leaner way of doing things. Okay, for more information, you can check out this one. And also the structure output is a string JSON. You can check it out. Yeah. So this is what I have to say. And yeah, finally, as what Derek was pointing out earlier, why even use agents when, you could make the LLM agent as small of the pipeline as possible. Most of the time, like unlike in the Claude web UI, like most of the time, if you are doing stuff for like enterprise, you typically want to do something really well, and your something that you want to do really well is typically not a flexible thing. It could be something as like you want to read a PDF, understand the PDF, and generate a report. This pipeline repeats many, many times, and you don't need an agent to do the whole pipeline. You don't need to choose the PDF reading skill, then PDF interpretation skill, then the report generation skills. Like most of the time, the steps are fixed in advance. So for this case, you don't really need the agent. Oh, let me just write this somewhere else. Most use cases have fixed steps in advance. So you know, no need to have the agent come up with the steps. Okay, we already know the steps. So what we can do is, instead of reading a skills.md for PDF reading, why not every time when the user uploads a PDF, we just run a fixed pipeline to read the PDF? Maybe you go through the VLM first, or you go through the text first, where it takes the text metadata. If it fails, then you take the OCR. If the OCR fails, then you take the VLM. Or you could just use the VLM direct. Like, why do we need the agent to learn how to generate code to read the PDF? No, when you already want to just read the PDF. Like, even if you want to fill in the forms, you could just like have a fixed process to come out with all the fields, and then maybe you just feed the field into the agent, and the agent comes out with the answer. They pass through this fixed process to fill up the form. Like, it's going to be more robust and more reliable than going through an agent loop, because the agent can make mistakes, and code that is generated can make mistakes as well. So PDF reading, just call a fixed way to do it. Don't even need the LM generated code here. PDF interpretation for this kind of very flexible things that the content can change. Then we use an LM or VLM to interpret the images and come up with some analysis and so on. And like stuff like more versatile, like report generation. Yes, we can use the LM to generate the report, use rule-based format to generate the citations and so on. So these are the kind of things that, this I call this agent LM rule-based hybrid. No, you don't use the LM agent for everything. Like, you don't wrap this whole pipeline up and say LM agent decide everything. Call whatever tools you need, generate whatever code you need. Very dangerous, very unreliable. All right. Agents are good, but you don't have to use them for the whole pipeline. So as this purple box mentions, each part of the pipeline might or might not use LM, and you already feed the context that is needed for each pipeline to each part, because you already know what each part is doing. So very, very similar to as now the earlier slide where you have the agents already having the context. Very similar in the pipeline, each part of the pipeline already has the context that is necessary for that part of the pipeline. So you avoid the step of retrieval. You don't have to do that. Each part of the pipeline already comes pre-built with what is needed. Right? So think about this and contrast this with what Claude Skills is doing. Do we really need to do what Claude Skills is doing, or can we do this approach? So of course, Claude probably needs to do the Claude Skills approach because they're trying to do one agent to do everything. All right, but if you don't have to have that design philosophy, maybe you can go into something more reliable like this kind of method, a pipeline method, or the hierarchical agents method like this. This, I believe, will perform much better than just having the skills retrieval as part of a step like in Claude Skills. Okay, I don't mean to do this whole presentation to shoot down Claude Skills. I think Claude Skills is still important, but it's only useful for context whereby you don't know the fixed pipeline. All right, but if you already know the fixed pipeline, then there's no need to do that. All right, that's my point. All right, so I just pause here for a bit. Any questions, comments on what I said? Like, I think this is the key thing for today, like whether to use rule-based stuff or fixed pipelines compared to using a very versatile agent to do everything. Yeah, maybe a few seconds if anyone. Yeah, sorry.
I just want to clarify what's your definition of agentic framework? Because to me, this seems to advocate for agentic framework instead.
You mean this PDF reading interpretation?
Yeah, so basically you have this is like a scaffolding, right?
Yeah, if it's an agentic framework, these 3 steps will be created by the agent. The agent will come up with the steps and then execute the step.
No, to me that's do away with the agentic framework. Because okay, my reference point was there's a paper called MetaGPT. So for that, they have very sophisticated coded out pipelines to do different tasks. Like, for example, you can be a software engineer, ML engineer. They have very explicit steps, logics to do that. So that to me looks like something like this. This is like a simplified version. But that's like a agentic framework.
Yeah, you can send me the reading. I have to go and see what you mean by that. Yeah.
So my point is like, if you have an agent, want to have an agent to do everything, right? Then for that that's like they're basically their direction they are moving towards to all those frontier labs, right? That's like do away with the agentic framework. But if you already have a fixed pipelines, you have a very clear uh task for each steps. That's like you can build. Actually, that allows you to build this scaffold for your subtask. So that to me, that's like a agentic framework.
Okay, so you are saying that people are already building this kind of pipeline as scaffolding for like an agent skill that can be used next time.
Uh, yeah, it's like how do you? To me, this is like very simplified version of a agentic framework.
Okay, I mean, you can
Yeah,
treat this as a component of an agentic framework.
yeah.
A pipeline being a component of agentic framework will work as well because you make your components very robust. Yeah, so that
Yeah.
mitigates more
Yeah, it's
errors.
just a matter of how what do you call agentic framework?
Yeah,
Not that I have anything in substance want to
no,
argue or
no,
anything.
no,
Yeah.
no problem. Yeah, so my definition of an agent framework is the agent decides everything. So agent decides the
Okay,
steps.
I
Agent
see, I
decides.
see. Okay, okay.
So what I'm saying is that, we can not do that. We can do certain pipelines in a fixed manner because we already know that it works. Yeah, so stuff like PDF reading, you don't need an agent to do PDF reading. You can just use a rule-based method to read. Yeah, so stuff like this, I think we can dissociate from the agent, and people are doing that already. They are doing function calls where the function itself can be very rule-based, and the agent just choose what rule to apply. So that works.
Wait, that's like we're going back to the paradigm last year, right?
Yes, yes. So the function, and you also can do rule-based pipeline execution like
Yeah,
what you
yeah.
did. Yeah. So I just want to say that yes, I think code generation very flexible and so on. It just comes with a lot of issues when your code doesn't work. And sometimes, just going back to basics might just be enough for your use case.
Yeah, sure.
Yeah, I agree with John's point. I mean, even with my own personal projects that I'm building out, like my task network or the planning task network is I run into the exact same thing where I just use strict JSON to build out all the functions and everything, and then I use that to build the larger architecture of the actual goal network and the actual like hierarchization and task prioritization and task breakdown. Like all of these different functions that are like symbolic and rule based of the actual hierarchical task network are all just made of strict JSON and uh, not really like a pipeline, but kind of like a basic LLM call, very basic LLM calls that all are orchestrated by essentially like a programmer who builds the actual architecture himself, him or herself. I don't discriminate. Um, but the issues, I think people are going back to robustness. I think most agentic frameworks are good for casuals. I don't think there's anything wrong with learning an agentic framework just to get used to it or familiarize yourself with LLM kind of neurosymbolic programming or like building applications. But I don't know if they're super serious for more serious programmers or serious developers who want to build very robust systems or very reliable systems for enterprise and other commercial use cases. I think a lot of people are just going back to basics because they know it works and it's so simple and reliable, and they can use that as the building blocks for whatever architecture, pipeline, workflow, system that they're trying to build out. As so long as the foundational building block is that secure and that reliable and robust.
Mm, definitely.
I
Yeah.
agree. So I think if you know your own task and pipeline very, very well, then this is definitely more robust. So, but I was just thinking of the example Manners talk about why they are basically trying to remove all this is because, like for their use case, user like I tried the agent before when I want to make some slides. I very lazy, so I want to give me a skeleton first, then I can just from there trying to revise, right? So the experience is mostly it's like the user, their user usually give a very underspecified task. So it's a very generic thing. Then they have no way to figure out what's the exact pipeline to do that. So I guess for that kind of use case where you have such an under-specified task, the agent really need to try out different things and to see whether it works or not. So then they really cannot be confined within a very rigid framework. That's why they want to remove all this scaffolding and let the agent itself to try out different things. Yeah. So at the end of the day, it's just a matter of different use case. Yeah.
Yeah, great discussion. So I would like to just continue the slides so that we can end. We can continue after that at the discussion. So this is a slide by Yen LeCun, one of my key AI inspirers. So he said that he's not so interested in LLMs anymore. The context of this is that he thinks that the better way of doing things is like world models where the agent learns from the state and the action and then like comes up with some maybe a latent space prediction of what's going on. So you can read his models called JEPA, Joint Embedding Prediction Architectures. He thinks that this is better than LLMs. To be fair, JEPA also uses transformer models. It's just that it's not like those kind of pattern matches in the input layer. It's more like, you predict a latent space. So you can check out his paper, JEPA. And why I mention him here is because LLMs as a way to do decision making, it is nice. It looks magical, but actually a lot of it is in the training data, and training data can go wrong for novel use cases. So instead of saying that, hey, I can have a general agent and general LLM that does everything, why not do a hybrid? So I come in my own quote. See, I use my own face here. Use LLM agents only if you cannot accomplish a task using rule-based methods. So I think I emphasized this over the past few months. I don't think an LLM agent should be used for everything because it's still subject to how good the LLM can interpret certain data. And LLMs are not trained to be decision makers. They are trained to come up with sentiments, extract data from text, and so on. So there's some limitation with using LLM agents to do everything, and sometimes you can mitigate a lot of errors by just using rule-based methods, like fix processes, fix steps in a pipeline. That's one way, or rule-based process to read PDFs instead of generating code to read the PDF is another way. So I think this is what Zeri was mentioning. Different use cases need different things. Like sometimes you need very versatile understanding of a document, then you need the LM to interpret it. So I'm saying yes, you should use it only when you cannot rule base it. Like if you want to find a sentiment from a document, it's very hard to rule base find out certain keywords to find out the sentiment, right? So for that, you use the LM. In fact, you don't even need the agent, you just need an LM. So again, use LM or LM agents. Yep. So I just want to highlight that this is, I think, the way ahead. We are not saying that LMs are not the best. Yan Lukun says not so interested in LMs. He's also still using some transformer in his model. Transformers are still very good. It's just that we need not use this kind of pattern matcher for everything. In fact, if you use an LM agent, you try to use LM agents, to explore a maze, right? You realize that sometimes they go to the same squares, same areas again and again, because this is the training data. So you also need some exploration mechanism, that I know sometimes randomly move and so on to explore the grid, the maze fully. This is just an example of LMs being like a pattern matcher to match something when sometimes you need something to explore more. Then you use a rule-based method to like complement it. Yeah. So like stuff like this are just some ways of how do we integrate LMs into our main application. So I'm not saying LMs are bad. I'm not that extreme as okay. And Lukun also didn't say LMs is bad here, but he did imply it in another talk where he says that LMs have a certain error that cannot be zero. Yep. I think it's fine. Yeah, nothing is perfect. What I'm saying is that you don't just use LMs only. You should also use rule-based as needed. Okay. So with that in mind, let's do a concluding questions to ponder. And I'm going to say the answer for each question first, and then I'll just ask whether you have anything else to add in. So first, how can skills be learned continually, and how can the skill library be updated? So I think for skills, the skill.md can be updated if a task succeeds and there is a pipeline that can be learned. So for example, PDF reader plus LLM interpretation, that could be a pipeline, and then you can store that as a new skill. So need a way to see whether the agent actions, agent trajectory is similar to existing skills. Okay, if different and skill successful at solving tasks, update skill library. So I think it's very possible to come up with a way to update more directories based on what has been done in other like settings. Or maybe you also plus a requirement that this skill is done at least X times, so that you don't just store in skills that only done once. If let's say the skill is useful for 10 times, then maybe add it to the skill library. I think you can do that. In fact, there's another thought that I have, like your skill library, your skill can also be a storage of past successful and failure cases. You can call your skills like maybe PDF reading history. So like with this with this one, your skills.md contains the past 5 successes and failures of calling PDF reading skill. So you can also do something like that, because to be honest, all these are just add additional stuff to your context, and you can also put the success and failure cases to your context. Yeah. So these success and failure cases can be need to know only basis. In fact, this can be stored in the PDF skill directly. Yeah. So there are different things you can play around with. I think this is something quite versatile. But again, as what I mentioned previously, the best case is you don't need to download any new info, because everything is in the modular component. So I still believe in modularity. Like if you don't have to download any skills at all, that is probably the best case. Okay, but if not, you could use your skills to store. You could store new skills in that. So in the modular case, maybe if something works well, it will be a new modular component. Yeah. So these are just some things that can be done with skills. Any comments or any discussion points you want to add for this? I think this is quite interesting about continual learning. Yes, Terry, go ahead.
In light of, okay, you mentioned that the agent cannot have too many skills at the same time, right? Otherwise,
Yes.
get confused.
Mm,
In light of that remark,
mm.
how would you suggest to, basically you want to continually learn, but then you also cannot have too many skills at a time. So how do you solve that problem?
Okay, so for this, we can look at the next two questions. I might as well answer them. Like, how many skills context can an agent load at runtime? I would say like 3 to 4 skills, based on my experience. You don't really want to have too many skills. So if let's say an agent has too many skills, maybe you can consider branching out certain parts to another agent. So once an agent has too many skills, you can modularize it by making it a sub agent, or a fixed process. So I think like the future shouldn't be one agent with everything, but an agent can continuously add new skills. But once you have enough skills, maybe you can consider making it a sub skill, like a sub agent with the skills. Like if you have 4 skills with PDF reading, all these 4 can go into a PDF reading agent. And then your agent will have fewer skills now.
Oh, so it's like once your number of skills reach a certain threshold, you spawn a new agent.
Something like that. Yeah, that's what I'm thinking.
I see.
Yeah. In fact, it would be even better if you don't even need to create a new agent, and just spawn a new fixed process. Like for example, PDF reading process. You just update that process, such that you learn all the new findings that you have and update that fixed code. So to the agent, how you learn that findings doesn't matter. It just executes the fixed code called read PDF. And you don't even need to know what history has been done and stuff like that. You just need to call that function. Yep. So that is even better than having a sub agent because you omit one other layer of the hierarchy. You just have a fixed skill you can just call. Um, yeah, I think that might be better. Yeah.
I
And
wonder if only knows the skill is sufficient, because like sometimes maybe the environment is very complex. So even if you know the skills, even you have the right skills, you still can execute in some wrong ways and get the wrong result. In that because of that, maybe the experience is still matters. Be it the positive or the negative experience, the agent might still be able to benefit from it.
you mean for more skills, from having more
Sorry,
skills?
I guess kind of task I have in mind is not like
Mm, mm,
software engineering use case. It's more like solving more complex um tasks. Yeah.
understand. Yeah. So actually, you might try to think about how humans do problem solving. Like we learn many different skills, but not all the skills are present to us at all times. Like maybe they are latently, but you don't activate them until needed. So I don't know, maybe we have like more than 100 skills in our lifetime, yet we are able to use different skills at different contexts quite well. I would say that there's a lot more things to do with the correct retrieval. And in this case, I was saying earlier, you do rack over the skills maybe.
Yeah.
Yeah.
That's also what I'm having in mind. You can rate on your skills.
Yeah. Oh, that's not I said that you can rack on your skills. Then I also said it was a bad idea because the embedding wasn't that great. What if the embedding improved? Then it would be a great idea. Yeah, just that
I
with
think we are actually doing right. Like we as human, we are actually doing right. Like cause we store some, like when you do your usual thinking, right? You are not you cannot process so much of your entire past life experience. I mean from when you have memory, like all the your life experience. So you only have like a very concise summary of certain
Mm,
very high level things. Then but when you find that certain knowledge become useful, then basically you are doing some kind of semantic search.
yeah, and the rack that we have is updated based on whether it's useful or not. So the more useful, the more it'll be prioritized. Yeah.
I think
So
we are doing some kind of quite sophisticated rag, um, sub not subconscious, maybe subconsciously, I don't know. But the point is like once you find the correct thing, then you can dig deeper then to get more info. Yeah.
there's some hierarchical retrieval going on. Yes. And also the rack is continually updated in some sense. Like you update it based on relevance. Like so if let's say something is relevant to your life, you tend to remember it more. So that by itself helps you retrieve it more easily. Like the memories, right? The more you think about it, the easier it is to retrieve. So there's some form of priority given there. And yeah, quite interesting. Like it's just beyond normal rack. It's rack plus some form of priority based
Because
on
you
retrieval.
said rag sorry.
Rack plus priority based mechanism based on
Yeah.
how
And
often
you
you
said the
retrieve.
reg also has problems similar to human case. We also have all kind of bias, like for example, recency bias. You have more fresh, like from a more fresh experience, you are more biased towards it. It's like you can think of it as a failure mode of
Yeah,
how we do
actually,
reg.
actually, it's true that we might use a form of rack. We might think that we are very capable, but actually, we only know of our successes. You see, if we fail, who will tell us that we fail? Like right or not? Like let's say you are doing a Sudoku puzzle and everyone is like, "Oh yes, I found the one of the best ways to do it." But there might be a better way to do it, or like you may not know that you haven't solved it. You might okay, like for example, let's not talk about Sudoku because Sudoku is optimization. We talk about stuff like I don't know, eating your meal. Okay, you might think that okay, yes, I should use a spoon and a fork to eat. Yeah, that's the skill that I've learned. But what if there exists a better way to eat that uses something that we haven't used before? Like we don't know that we didn't come out of it. It's like if someone were to look at us and they say, "What is this human doing? Why are they using for a spoon to eat? Why don't they use like another mechanism that is so much better?" Like So to us, when we look at the LLM agent, the LLM agent is like, why is this LLM agent generating so much nonsense code? Just use this line of code, but it's not getting it. Why is my Claude Code agent running 100 iterations and still not doing it? So to us, because we know how it's done, right? Then it's like, why is the agent not doing this? So somewhat similar to humans. Like sometimes we think we know what we're doing. It's like, oh yes, I need to do this 100 things. But someone might be looking at us and like saying, how come he's doing so much nonsense stuff? Yeah, yeah. So that could be the case. Like we might be doing RAG, we might have failure modes, but we don't know that we failed.
Well, my concern is that when we talk about that and try to do some kind of rack blunt, if we envelop this idea and we play it out, and we get enough layers of hierarchy and separation between skills and relevance, do we make room in this system for planning? Is planning going to be a tool call, or is planning going to be an entirely different function that runs with, say, the pipeline or the agent to allow for high level? Because I think the issue is that lower level extraction is fine. We can just separate all of our tool calls into all kinds of different layers of hierarchy and relevance. I think higher level abstraction is where it becomes an issue, because if I give my agent or my pipeline hybrid, whatever you want to call it, a certain task that's complex enough, and I don't feel the need to, spend a year trying to code out every single piece of possible pipeline or possible workflow I need to fully accomplish the task, and I want to somehow automate it to an agent or to a separate use case, then I think we run into issues where I think JU was talking about it earlier, where your agent can kind of do like the prototype or do some kind of like scaffolding, I think, in order to avoid the full workload. But I'm not sure how we would integrate like some form of arbitrary planning into this kind of, I don't know, we call it like system or pipeline. I'm trying to avoid calling it like agentic workflow. But there are times like you brought up where you need like higher level planning and abstraction when you want to automate certain things that you don't want to build out by yourself. You don't want to build out like 1,300 different workflows and pipelines just to accomplish a task when you can possibly automate it with a self-adapting agent.
Mm. So actually, I do like this whole point on planning and stuff. So I think planning might actually be, I mean, in my opinion, it might be a form of simulation where you can simulate many future possibilities, and then like come up with a plan. Or this is one way of doing planning. You plan by simulation, and then you come up with something that it looks good. Or you could take past examples, take past trajectories, and come up with a plan. So basically, like in the past, you do X, Y, Z. So maybe this time around you should do X, Y, Z because it works. Or last time you did X, Y, Y, it failed. So maybe now you try something else. You try ABC. So there are different ways of doing planning. I'm more of the approach that a simulation-based method might be better because sometimes your past experiences may fail because things have changed. So if you could simulate this, especially if you have some form of stuff like a world model that you can maybe call a function and see whether it works in your world model, then you could do planning like that. Yeah. So I think planning it's going to be separate from the main LLM agent step. It's going to be an additional module that the agent has. And if you have a simulator, you can run the simulator to do the planning. Or if you don't have the simulator, you can extract out past memories to do planning. Yeah, so that's my idea of planning. Yeah, if that answers your question, Derek. Yeah.
Somewhat, yeah. I'm still thinking about the relevant. I'm trying to relate it to our issue with the skill library, because we are going to run to a point where the self-learning agent is going to build such a massive library filled with so many folders that we're going to need some new way to organize and maximize our utilization of the library, other than basic even RAG plus. I think RAG plus is cool, but I think you're still going to run into latency issues because there's only so much RAG you can do in your library when you're trying to like minimize the loading everything. There's just going to be a lot of folders to sift through essentially in the hierarchy. I think something like planning would be ideal. Take a page out of Evolution's book and try to implement some form of possible simulation or some other form of mammalian planning and try to integrate it into these more advanced agents. Maybe the simpler agents are always going to be rule based, but I think like once your agent gets such a massive level of memory from self-learning, I think that's when you start to run into issues where you have to start thinking about higher level things like planning. But I'm thinking really far ahead.
What if your agent can like learn its own weights again? Like, so instead of just having external memory layer, you could have the agent learn, like, for example, this task, you should call this tool. Like, you can train it using fine tuning. Then, if you fine tune enough, maybe you don't have to have the skill library, right?
Okay, so right. So pretty much you would build up your library, and then once your library gets big enough, you just consolidate it into weight parameters and fine tuning, pretty much.
Yeah. So
Which yeah.
initially, like for the starters, you might still use external memory because your fine tuning is not done yet. But once you do more tasks, you fine tune it. Actually, you don't need the library anymore. It's already given this task, you already know what action to do, like based on your fine tuning.
Okay.
Yeah.
Yeah, I
So,
think a lot of papers do that. So pretty much in this context, we're treating the LLM as a form of, I want to say, long-term memory, or like
mm, mm.
maybe like what's the
Yeah,
word?
you
Like
can.
compressed memory.
Yeah, compressed memory, and it's also is updated slower, but eventually you'll be updating it. Like muscle memory also is maybe because you train the LM in your head, you train it enough time such that you don't have to think about the details anymore. You can just execute stuff.
Right, yeah. No, I'm right. Yeah. So you're pretty much your long-term memory is going to become the parameters, and then your short-term memory is just going to be the active skill library that you constantly update quickly.
Yeah,
And then
and
eventually,
in fact, when
yeah.
you reach a stage whereby when you get the task, you straight away get the action, you can remove that from your skill library because your skill library are for things that do not exist in the or things that exist imperfectly in the LM weights. Once the moment your LM can generate the thing quite reliably, you don't have to have the skill library anymore.
Okay, so the skill library becomes almost like its own data set as a source of data for the LLM to fine tune on,
Yeah,
so it can
and
specialize towards its own environment. Okay.
and you can remove it once it's done. So it's a bit of a stretch for current tech right now because we don't really fine tune LMs that much. But once you have your own LMs, you can fine tune it. You can fine tune on the agentic loop itself, it will perform better. The downside, of course, is that the LM might over specialize in certain tasks and not be general anymore. So, as with all things, um, your LM, the more you fine tune, the less general it is, especially if you fine tune it on specific data. So, then we need to talk about population level growth. So this one is basically like different LMs or like humans have different personalities, they learn different things. So you have diversity in your population. So when something is needed in a population, you just learn from the best. Yeah. So it's a population level growth and diversity. So it's saying that, once we do this inner loop of fine tuning and building the skill library for every single LLM or person, you don't do it the same way of fine tuning for every single person. You keep some diversity so that in the case you want something different, you can learn from someone else or some LM that you can get better results from as compared to everyone being the same. Yeah, so this is a population level diversity here. Quite a lot of factors at play. It's going to be hard to simulate this. And the main thing is that you want to learn continuously, but you don't want to put all your eggs in just one person or one LM or one agent. Yeah, you want many agents. Yeah, if that makes sense. Yeah.
Yeah, I agree.
Yeah. So this one is beyond Claude Skills, but I think this is a great discussion because I think we are heading towards that self-learning, continual learning. And my takeaway is that you can't do it with one agent. Just now, you just take a look at how I implemented Claude Skills. Uh, yeah, just a single LM itself, can have so many mistakes already. You need to prompt it in a very fixed way. In fact, your user task might switch a little bit and your agent doesn't work anymore. But if you have many agents, you switch your user task a bit. Maybe someone's agent is very used to seeing this kind of input. Then that person can solve it. So multiple agents, multiple pipelines of doing stuff might be even more robust than just having one. And yeah, I think that is something that can be simulated. So this simulation here, what planning should be? This simulation here, you can talk about single agent, or you can talk about multiple agents also. And I'm more aiming at multiple agents because I don't think one agent can solve a lot of things. Yeah, like if you just take me, like one person, you give me all the problems in the world, maybe I can solve less than 1%. But if you give every single person in the world all the problems in the world, maybe we solve 10%. Yeah, so there's advantages in groups. Okay, very good discussion. Actually, I really like this evolution thing. Maybe we'll talk about evolution next time. Yeah. Yeah. So yeah, should we last question, should we run a fixed pipeline or rely on an agent's dynamic code generation? So I would say that fixed pipeline whenever possible. Yeah. So going back to this skill library things and fixed pipeline, no, once the moment the agent has internalized this pipeline, yeah, maybe it could just be a tool call for that fixed pipeline. That's one way. Another way is that we don't have the agent to do everything. Yeah, we do the PDF pre-processing as one step, then we do the agent, and then we do like maybe post-processing as another step. That's a practical pipeline. So different ways to implement it. If you want a totally fully flexible agent, then my advice is to just do a fixed pipeline as a tool call, as a skill or tool call. Yeah, so that you reduce complexity. Yeah. You might be able to fine-tune your agent to do like PDF processing also perfectly. That's another way to get it done. So different ways to do it. Yeah, depends on what tools you have at your disposal. Yep. So, but my advice is, if possible, if you don't need the LLM, don't use the LLM. Yeah, that's the advice I have right now because LLMs are still pretty much dependent on the training data. It's very hard to override the effects of the training data unless you can train it on your own. Yeah, from scratch. Yeah, so if not, it's very hard to eliminate the bias from your training data. Even you fine tune, you find that you cannot fine tune to the extent that you want. There's still going to be artifacts from your training data that will spill over. So yeah, this is the current paradigm we are in. I still think LLM agents are great. I still think dynamic context loading is great. But if there's if there's no need to do dynamic context loading, you should just do modular pipelines and do it is much better. Okay, last 1 minute, anything before we end for today? Okay, if not, thanks so much for staying. I know we overshot quite a lot. And let me just go back to the slides again. Yeah. I like to say that plot skills is a very interesting way of doing the agent whereby you can load the context dynamically. But more interesting is if we can make the pipeline more composable, more like modular, such that we don't even need this, we can just do something like this. Okay, eventually, is there a way to make your agents become more like a pipeline rather than a full agent structure? So that's food for thought, and I will leave you on that. And yeah, thanks for joining the discussion today. Okay, bye, Ren.
You. Bye.